Good morning, everyone, or afternoon or evening, depending on where you are in the world. Today we are doing AI for part of the IGDA's Webinar Wednesdays, and we are very proud to today be hosting Julian Tegelius, who is one of the foremost academic researchers in the field of procedural content generation. So those of you who are frequent attendees of AI sessions will have seen that this is a topic that we've brought up a couple of times in an industry-facing kind of way. And today we're going to hear from pretty much the most prolific researcher in the field. I'm pretty sure that Julian actually has a procedural paper writing engine, and he just slaps his name on the top of everything.
Right.
So without further interruption, I will turn it over to Julian to tell you all about procedural content generation in games.
Yes, thanks a lot, Luke, and thanks a lot for inviting me. It's my pleasure to be doing this. And I'll, of course, try to tell you absolutely everything about procedural content generation in games in 1 hour. That will be no problems at all. Anyway, so I'm not done a webinar before. The way I'm treating this is I'm giving a talk. I'm assuming you're listening. I'll forgive you for not laughing at my bad jokes, etc. If you want to ask me anything, you type your questions in this questions tab in the webinar software, and then I will check them periodically and try to answer your questions. Good. So I call this procedural content generation in games, perspectives from the ivory tower. It's my title, so no one forced it on me. And just a few words about who I am. I'm just going to try to remove this control panel. Good. Now I can see my own slides. Good. So I'm currently sitting in the town I'm in, Malmö, in Sweden. I've had a sort of complicated academic path, working in Sweden and England and Switzerland, and I'm just about to move to New York University. I started studying philosophy and psychology. Decided I want to understand the mind, so I went to artificial intelligence or robotics, and decided I didn't really have the patience for that either. You know, philosophy moves too slowly, and robotics you need to basically use screwdrivers and change oils or whatever you do with robots. So I decided games is great because you can, basically answer lots of artificial intelligence questions and test them using games as your benchmark. Then I started doing this, and I discovered that, hey, games have lots of really interesting questions to work on in their own right. In particular, lots of interesting questions that can be answered or can be attacked by artificial intelligence. So I started getting into player modeling and procedural content generation, and I also do NPC behavior and all kinds of things that have to do with artificial intelligence and games. It's one of my favorite techniques is evolutionary computation, but I'm sort of method agnostic. I use whatever is right for the problem. Right. Just a word of caution. I'm from the infamous ivory tower. This is an ivory tower. Well, what I mean with this is that I'm basically an academic researcher. I'm working on things, basically sitting in a university, thinking of problems, trying to solve them in various ways, and I don't necessarily always think of the bottom line in how is this going to be profitable for my company right now. In fact, I almost never think about that, which is pretty great actually. Unlike many of these other people that the IGDA is basically meant for, which is all these people in the so-called industry, that I imagine all these game developers working in some kind of factory doing, games and stuff, and it's dirty and messy, and you have to eat stale bread. Maybe it's not exactly like that, but I just want to point out that there might be a difference in perspective. But I'm very much interested in all kinds of dialogue, especially with people who don't usually sort of study at the academic, study topics from an academic point of view. And I think there's a lot of fruitful dialogue in between here to be had. Right. There's more you can read on, even while you're watching this. If you think I'm not moving fast enough, or if you want to read more afterwards, there's my webpage, julian.togelius.com. And there's also the PCGbook.com, which is a community effort led by me and a few of my colleagues to write the first textbook on procedural content generation. I hope you will find that useful, and we're very much looking for feedback on it. By the way, if you think that if I'm not coming through clearly or anything like this, please write something in the question box so I can see it. Right, starting, what do I mean with procedural content generation in games? So I'm talking about with none or limited human intervention through the use of algorithms, generate content. So content we're talking about not NPC behavior and not the game engine, not how things move about in a game, but essentially everything else. And we're talking about games, all kinds of games, computer games, board games, any kind of games. There will be examples mainly from computer games in here. And game content, there could be lots of things. There's lots of work on levels and tracks and maps and so on, but could be all kinds of things, vehicles, personalities, camera viewpoints. And we'll also look at generation of the actual game rules themselves. Okay, let's take a few examples. A quick historic odyssey here. Elite, this classic game where you fly around a spaceship. There's a new Elite coming out basically in a couple of weeks' time, or something like this, or a couple of days' time, which will be, which I'm very much looking forward to actually. But let's talk about this old classic Elite. You flew around in a spaceship in a first-person view. There were these various solar systems. Each of them consisted of planets, and they had various. Each planet had a space station orbiting around it. There were lots of different solar systems and a pretty huge galactic chart. Thousands of space stations in there in various places, and all of them had different different commodities with different prices, and they had missions and everything like this. And the pretty amazing thing with this is that all of this fit in memory on a Commodore 64, which is pretty remarkable because a Commodore 64 does not have 64 gigabytes memory or 64 megabytes, but it has 64 kilobytes of memory, which makes you wonder how could you possibly fit all of that into that limited memory space. Well, the answer is that they didn't really. They used a lot of sort of clever generation techniques in runtime to create all this content, and they basically used the program code itself as seeds to the random number generator. So every time you sort of traveled into star system number 273 or something, it would recreate the whole star system with everything that was in it, positions of pirate ships and police ships and freight ships and prices of spices and so on and so on, just from scratch, based on a simple random number. So procedural content generation, one of the roots of procedural content generation back in the early 80s was a form of data compression. We just didn't have space for all these huge worlds. And you might think that we don't have that problem anymore because we have more than 64K of memory. We even have more than 640K of memory, which should be enough for everybody, right? But the issue is that, I mean, we want to represent insanely detailed worlds. I don't know where you're from, but I'm sure that there is a level of detail at which your hometown is too complex to fit into memory on your computer, or even on disk. So it will need to be regenerated in some sense. The other root of procedural content generation is essentially the need for replayability and the need for and getting rid of the effort of writing all these stories. So this is Rogue, this dungeon crawler from about 1980. Toy and Wickman made it. It has, as you can see, state-of-the-art fancy ASCII graphics. The really amazing thing about this game is that every time you start it, you will be able to move around and explore a completely new set of dungeons with different levels, and there will be monsters, there will be enemies, there will be collectibles that you can use to power up yourself and level up in various ways, new weapons, new items, and so on. You know nothing of this from start, it's all randomly generated. Apparently, what Michael Toy and Glenn Rickman wanted to do was that they wanted to make Dungeons and Dragons into a computer game. But they had a couple of problems. One was, as we heard before, they didn't have enough space in memory or on disk to actually do this. The second was that they didn't really feel like writing all these adventures. And the third, perhaps the most important, was that, well, if they were going to write all these adventures themselves, they wouldn't have any fun playing it because they already knew what was going to happen because they wrote the adventures. So instead, they decided to go for actually generating everything in the game as you went ahead. Rogue has had a very large number of successors in its own genre. They're called roguelikes. So the Diablo series, you can talk of them as roguelikes. These are the famous games where you click on monsters until they die. They're very popular. But they retain this feature that you have that all of the level is generated on the fly as you go along. Dwarf Fortress, which many of you might know, is in the same genre. It's a technically extremely impressive thing that generates the whole history of the world as you start playing. It simulates the world down to such detail so you can have different socks on the left and the right foot of your individual dwarves in this massive dwarf fortress in this enormous world which has politics and gods and geological formations and whatever. It's very interesting. I'm not sure I would consider it actually playable, but hey, interesting. Spelunky, on the other hand, is an absolutely truly excellent game, which is essentially Super Mario Bros. Meets Indiana Jones in a roguelike. There is a procedurally generated world. Every time you play it, you get completely new levels, and you have to make it to the end. It's very hard. Yeah, I've actually never managed to finish it. But it really relies centrally, like more and more games do now, actually, on having the world regenerate as you go along. But there's also more conventional FPS games. This is what a typical, well, not so conventional FPS game, but it's a big budget title, Far Cry 2 here. It has procedural generation in the sense that you move around in this huge jungle. It's always the same, you know. Every time you play it, you have the same jungle. But it's just too huge and too detailed to fit in memory, even on disk. So the details of it will have to be regenerated as you go along. There's also the fact that certain aspects of the story are replanned depending on what you do. For example, if you shoot an important quest giver, someone else will become the quest giver. So that's also a form of generation of narrative here. SpeedTree is a very ugly picture here, but SpeedTree is this software which is used very widely for generating vegetation in I think hundreds of games, hundreds of AAA games. So basically generating bushes and trees and grass and so on is essentially a solved problem. We have algorithms for that now. You don't have to do it anymore, which is great. When you think about it, William Gibson wrote at the beginning of Neuromancer, I think, about some time in the future where people were employed for making things such as plants in virtual worlds. You would think it was forward-thinking, but he didn't. Even William Gibson didn't foresee procedural content generation. Another game which is relies completely on procedural content is Civilization 4, or like any game in the Civilization series. The whole point of the game is you don't know the world when you start playing, so and you have to explore it. Therefore, it needs to be generated as you start. Borderlands, one of the in FPS, one of the main arguments of this was that it had something like 16 billion weapons or something. It didn't actually have 16 billion weapons, but it had the possibility of creating such a vast range of weapons and other items through various recombinations. A game which you might not know about, I will unfortunately not have time to talk any more about this. It's a game by Aaron Hastings and Ken Stanley. which is called Galactic Arms Race, which very interestingly generates new weapons for the whole game as you go along through a collaborative evolutionary algorithm. This is something you will find more readings about this in the PCG book, and you might check out the individual and the original papers as well. To take another academic example, this might look like a boring board game, and in fact it is just a board game, pretty good board game. Well, the interesting thing is that the board game was not designed by a human, it was designed by an algorithm. Right, I'm going to go on and talk more about this. I'm just going to see if there were any questions so far. Opening the question tab. So we have someone saying that he can't hear anyone. Anyone else has problems hearing me? Please type it into the question panel. Okay, I'll go on in the meantime. The questions we try to answer here, I mean, the reasons why we want to use procedural content generation, there are several of them. One is that we might be able to drastically cut game development costs by creating content automatically. So can we do this? Can we sort of basically just have designers have, you know, opinions, visions, and all the sort of things that people like to have, and then tell the computer, like, here's my vision, now do this, you know, create the content. Which would be great. There's one vision. Can we create games that adapt to game worlds to fit the preferences of the player? So basically, as you go along, the game figures out that, well, this player seems to like more of this, less of that. Now we basically recreate the game, create new levels that fit with this particular concept. That could be interesting. So basically they adapt to you because, you know, currently we have this sort of one-size-fits-all development model. You create this huge big budget game that costs like $100 million, and then you can't afford making very many versions of it because it's so expensive. But players are very, very different. So could we use it to help adapt to to players? Can we create endless games? So, you know, you start playing Skyrim or Grand Theft Auto or something like this, and you're placed in the middle of a medieval world or in the middle of Los Angeles or something, and you go explore. The problem is it's not really that big, you know. It's a couple of kilometers big because it's so expensive to create all this content. So I would like to have a Grand Theft Auto game where you basically, you find yourself in the middle of a city, and then you decide that you want to go, you know, I want to drive south by southwest, random direction. I drive for 5 hours. And when I stop driving, there should be something else there, maybe a new city with new inhabitants, new buildings, new unique architectonical features, and new missions, new intrigues going on in this city. Why don't we have that already? So this is one of the visions we'd really love to be able to make reality with PCG. Also, humans are not very creative. They like to think they are, but basically humans keep copying each other and keep coming up with essentially the same CAM solution, thinking inside the box. Maybe we can use algorithms to augment this. Maybe we can use algorithms to come up with new solutions humans wouldn't have thought about and augment our creativity. Also, finally, another reason for studying this is that how we do game design. I mean, quite a few people are studying game design, but as anyone who writes code for a living or even knows how to write code knows, we don't really understand our process until we've written code that can recreate it. So if we really want to understand game design, we need to create code that can design games. At least I think so. So that's yet another interesting interesting reason for doing PCG. So let's say we have a content generation problem. We need content of type X for game of type Y, and it needs to be here for some reason. What sort of criteria do we have? Well, we might want to have it fast. I mean, it might be something that happened between each frame, or in a millisecond, or maybe it's something like, you know, something that doesn't need to change with different players. So it might, you're doing it at design time, it might need to take a week or so on, or you might allow it to take a week to generate. You get a different sort of different demands on how fast it should be. There's the issue of reliability. So what if you have a content generator that usually generates very, very nice levels, but sometimes they're unplayable? Or, you know, it generates a completely new item for you to use, but sometimes it generates items that you can't use that blows up in your face and crashes the game, you know. So you might have strong demands on playability. It completely depends on what sort of content you're making and where it fits into the game. Controllability, especially if you are making an adaptive game that's adapting to the player, or if you're a designer that wants to have an input on the content generation process. You have all these demands on controllability. How can you control this process? How can you sort of make this, how can you tell it what you want out of it? So I want a couple of new characters that's going to be populating this city square that we just generated, and we want them to be talk about this and that, and we want them to be of this size. Can we also sort of specify what we want from them in some other way? There are many ways in which you could potentially control a content generation algorithm. And you might also want it to be able to have an expressive range where it creates diverse content of different kind that doesn't look the same. And you might want to you might put a big premium on creativity, that it really looks like something that you haven't that hasn't been done before, and it's not just basically copy pasted by a computer. You'll find that if you design a content generation problem, you'll have a lot of trade-offs here. So lots of what you find in these in these commercial use PCG is very fast because it's used in real time, and it has high reliability because it's very, very tightly constrained, but it's very low controllability, very low diversity, and very low creativity. So that's typical for roguelike dungeon generators. Or if you play Diablo 3, you know, these are there are different levels every time you play it, but after a while you notice that they look very, very samey in different ways. Spelunky is an interesting Spelunky is an interesting exception here because it has relatively higher creativity and diversity in many of its levels, because it's designed so that reliability is not really an issue. Some levels are complete messes, but that's fine. You can bomb your way through them or something. Now, let me move on to the next big chunk here. I'm just going to see if there are any questions so far. There appears to be no questions. I'm going to lift out the question panel, I think. Oh, okay, right. Okay, there's a... So we have someone saying that I found that adding an error to Chris Crowell points out, I found that adding an error to procedural AI makes it feel more human. That's true. Even though it's more a point about NPC behavior, we have found that ourselves when we're trying to make believable bots for playing Super Mario Bros. Or playing some other FPS games. And that's a really interesting point, actually, especially having the player or the agent wait and look like it's hesitating for a bit makes it look much more human-like. Would the same work for level design? That's an interesting point. My intuitive answer, this is Chris Crowell asking the same, because that's how people work. We stumble forward. Yeah, my intuitive answer is no, because most levels that you see are rather over-designed because you put so much effort into them, and people are really worried about making mistakes, so that's what you have quality control for. I'd personally much prefer levels with more mistakes that actually look more interesting. I think it's an interesting analogy, but I think that levels with errors in them would actually look more computer generated. Maybe a larger range of parameters so that the levels can have more variety. Yes, Chris, I agree. Would be a good idea. I'm going to move on and talk a bit about search-based PCG here. I'm going to move this panel here, which is a set of techniques that's widely researched in academia currently. It's not found a lot in commercial games. There are a couple of exceptions, such as City Conquest, which is a pretty interesting real-time strategy tower defense hybrid, and which uses evolutionary algorithms for balancing. So the basic idea is that you use evolutionary algorithms or similar methods to create your content. Now you might wonder, evolutionary computation, what is that? It's essentially just Darwinian evolution in a computer. So you keep a population of candidates, you measure the fitness of each candidate, remove the worst candidates, replace with copies of the least, or the best or least bad candidates, and mutate cross over the copies. Just like rabbits, you have a population of rabbits, and there are lots of them, and then basically the fox takes the worst rabbits, so they don't get to reproduce. Because if you're a rabbit and run away from the fox, you don't actually need to run faster than the fox. You just need to run faster than the other rabbit. And over time, because the faster rabbits will have more rabbit kits, what are they called? Rablets? Then the assuming that there's some heredity to the speed of the rabbits, the new rabbits will be faster. There's always a mutation going on, so random changes and crossover, because rabbits sort of it takes two rabbits to make new rabbits, and it's a combination of them. So it's basically the same thing here. You just have an algorithm here. There are lots of different types of evolutionary algorithms. They're called genetic algorithms, evolution strategies, evolutionary programming, etc., and similar algorithms called particle optimization, differential evolution, and other such algorithms. Very often, when trying to actually use this, it's a good idea to use a simple algorithm that you actually understand and can be written down in not so many lines of code. I often use a simple, it's called a mu plus lambda evolution strategy with no crossover, which literally can be done in 10 lines of code. And it often works well enough for many of the problems you want to use an evolutionary algorithm for. It works like this. You have a population of mu plus lambda individuals, and for individuals here you can think about quests, levels, sets of rules, weapon parameters, whatever. So, and you have a number of generations. Each generation, you evaluate all individuals in the population using some evaluation function, and seeing how playable the levels are, how novel the weapon is, or how intricate the quest is, or whatever. You get a value which is called a fitness. You sort by this fitness, so you sort them in order from the highest, the most fit to the least fit. Initially, all of these are randomly generated, so all of these are pretty bad. But you will be able to discern that some of them are less bad than the others. You remove the worst lambda individuals, so perhaps the worst half, and then you replace those that were removed with copies of the best, so the best half, for example, and then just mutate these copies a slight bit. This is really a sort of criminally simple algorithm. You really could have thought this out yourself if you didn't already know this, but that's fine, it works. There's lots of tricks and intricacies to making this work. In particular, you need a good representation of whatever it is you're evolving, and you need a good evaluation function. But so you can spend basically a lifetime learning how to really make good representation evaluation functions. But the core of the algorithm is insanely simple, as you can see. A conceptual tool for understanding how evolutionary computation works is the fitness landscape. So say that you have genes, which is whatever specifies your level or your character or your quest or whatever as a set of numbers. So we have two numbers here, say along the x and y axis at the bottom, where it says combination of genes. And at each point on this plane, there's a fitness, and the fitness is the height of this landscape. So what happens is the selection usually pushes populations to the top of some peak. So you get larger and you get higher and higher fitness. So before we go on to the next, do we have any questions? Can you use the algorithm to generate geography drawing from different libraries? Asks Rob Stamper. Yes. Depends on what you mean with different libraries. You can certainly evolve. Geographic information, or you can evolve landscapes. We're going to see one example of evolving maps soon. But if you go to the PCGbook.com website that I had in the beginning, you'll find a chapter particularly on landscapes and textures. So chapter 4, where you find a couple of examples of this. So there's a couple of different, and I think some in chapter 3 as well. There's a couple of different approaches to evolving landscapes and geographical information. I'm not sure what you mean with different libraries, but yeah, maybe you'll can write down a more specific question. In the meantime, we'll go on here. So, if we want to evolve levels for Super Mario Bros, how would we do then? I'm using Super Mario Bros as an example because it's extremely, it's an extremely well-known game. It's an extremely good game as well, but it's and it's also conceptually simple. Everybody knows what goes into a level here. So we have this thing called the Mario AI benchmark, which is a reasonably faithful clone of Super Mario Bros. 1 or 3. We have APIs for level generators and AI controllers, so you can use it to test your various AI and AI algorithms, and you can also use it to test your level generation algorithms. It's based on Infinite Mario Bros. By Marcus Persson. So Notch, before he became famous, he wrote this, and we retooled it into an AI benchmark. You find it on marioai.org. Using this, we decided to create new Mario levels using evolutionary computation. So the basic thing we did was that we started with identifying a number of vertical slices. This is work mainly done by my PhD student, Steve Dalskog. They identified from the original Super Mario Bros. Levels. So a vertical slice, as you can see here on the picture to the right, is a slice from the bottom to the top of the level, and several of these are identical. So the first, if you look at this picture, the first slice, the second slice, and the fourth slice are actually completely identical. So we can call them slice 0. The third slice is different, so we can call it slice 1, the one with the question mark, and the fifth slice again is also different, so we call it slice 2, for example. So we can have quite a number, many fewer slice types than there are than the length of all the levels together. And then we represent these levels as strings, where each character corresponds to a pattern or to a slice. We call this a micro pattern as well. So you could, a whole level, say that we have a library of 25 slices, which is something like what we found as the 25 most common slices in all these levels. And then a whole level would be, say, 200 or 300 characters long, where each character map into one slice, which is a very sort of compact and nice representation. And then we need an evaluation method as well. So we came up with these 25 meso patterns, so we can just call them patterns here. So things that often stand out as designed features in the level. So hordes of enemies, valleys with pipes on each side, 3 paths. This particular image here shows a 3 path. You can go down below, above, and at the very top. These stand out as like, they look like, they're there for a reason. They're there to actually elicit some kind of gameplay behavior from you. They pose a challenge to you, the player, and you need to, which you need to overcome in some sense. And the fitness function, basically, we have different versions of this, but one version here is that fitness function counts the numbers of patterns found in a level. So the more patterns, the better. And then you can get levels like this. So this is completely procedurally generated using evolution. You find a paper reference at the bottom there. You can find normal papers on my webpage if you're interested. We did a couple of simple user studies for this, and it looked like these levels that were evolved to have as many patterns as possible were judged as more interesting by players than those that were not evolved to have many patterns, or that were even evolved to have few patterns, which tend to be rather featureless and feel meaningless in a sense. I think I got a question here. So basically, I'm getting a question about being able to hear me.
Hey, Julian. Other people commented that they can hear you, so I'm trying to troubleshoot with this one individual. So
okay,
you're fine.
Okay, good. I'll go on then. Thanks. Right. Let's look at something else because you might think that Mario, Super Mario Bros. Is a very simple domain. You know, you have linear levels, you have and they sort of, well, child's play, like really, they're simple to get through. On the other hand, you might also say that Super Mario Bros. Has some of the greatest level designs in the world. I mean, Super Mario Bros. World 1, Level 1 is masterpiece in level design, but there are so many other things you can generate. So have a look at a map generation for real-time strategy games. So to take a really, really hard challenge, StarCraft. You all know StarCraft, Korea's unofficial national sport. They have TV channels for showing StarCraft matches, which is, I guess, a sign of civilization or something. You have 2 or 3 or 4 player competitive matches. This in Traces is a masterpiece of balancing. You have different map features. So here's an example map. You see this red little thing at the top left of the map. That's one step to starting mission for a base. There's another one at the bottom right, which you might not be really able to see. You have passable terrain, which is most of it, impassable terrain, which are those rocky parts, and then you have these blue things, which are resources. So we have 2 types of resources, but we can talk of them as like put them together. Just for now, you need resources to grow your base and to build units, etc., etc. I'm not a very avid StarCraft player at all. So what we decided was that we decided to try to define what was desirable traits from our real-time strategy game maps and operationalize these traits as fitness functions and define a search space for maps. Then we were going to search for maps to satisfy the fitness functions as well as possible. Given that we have not one, but several fitness functions, we decided to use multi-objective evolution. So looking for the optimal trade-offs of these different fitness functions. This gets pretty complicated, so I'm not going to go into any details here. If you want a nice intro to search space PCG, the previous example is much better, but this is an example of what can also be done. So we decided that a good real-time strategy game map would be playable, so it should not put your base starting positions right next to each other. You should have sufficient room around your base to start growing it. You should have some resources close to it, and so on and so on. So a couple of small, simple things like that. Then it should be fair. There should be equal number of resources claimed by each player. There should be, or like claimable by each player. There should be equal, sort of equal length and equal distance travel to the first resource. They should be things such as having the same amount of protection, etc., from attacks. There should be, and then there should be features contributing to skill differentiation and interestingness. So we looked a lot here about at the paths that people would take from one base to the other. We looked at the presence of choke points. It's a good thing if there are choke points where you can, with a lesser force but a better strategy defend from an overwhelming incoming force because there's a narrow pass, for example. There's also an interesting thing if you have several players where the paths cross each other, so you have skirmishes that were unplanned. There are lots of possible features here, and we encoded these. We designed something like 12 or 13 different fitness functions. Let me see, here's an example. Playability fitness functions, base space, and minimum distance between bases. We used A star. The distance from base to closest resource. Well, I talked about this before. That's fairness. And choke points and path overlapping are skill differentiation fitness functions. So here's an example of a very small evolved map that we had resource fairness and choke points in here. And you can see that it is evolved to basically satisfy this. There is a choke point really close to the blue base down at the bottom left, and there is approximately the same distance from each base to the nearest resource, and they have the same number of resources on their own side of the map. However, we showed some of these evolved maps to StarCraft players. Yeah, here's a 3-player map as well. And on like a large number of StarCraft players on a forum for avid StarCraft players, and they basically told us it was terrible and useless and pointless. And we had them answer questionnaires and ask what's wrong, you know. And it turns out that they basically said that, well, these are maps are like by definition not playable because they're not symmetrical, and we were sort of dumbfounded. Really? Why should it be symmetrical? We thought it would be uninteresting to have symmetrical maps because then you know exactly what the opponent's territory looks like. Nope, StarCraft players want symmetric maps, period. Okay? And then they started pointing out lots of sort of very minor details, and they were really, really obsessed about the fine details of the balance of these maps, which is, when you think about how StarCraft is played as an extremely competitive game, it sort of makes sense because it's not about novelty and it's not about exploration. It's about like extreme fine-tuning. It's like these kind of racing games where you play like 100 laps after a starter just to be able to shave milliseconds off your lap time. I never understood the appeal of those. I mean, I like Mario Kart where you can hit people in the head with turtles, and I like strategy games like Civilization where you don't really know what's going to happen. But the big takeaway from this is that even if you put lots of interesting effort into your algorithms and manage to satisfy your objectives in a numeric sense and engineering sense, if you don't know your player population, you are not going to be able to give them what they want. So in the future, I will not be dealing with StarCraft anymore because I don't understand those players. I'll be dealing with players of and people that play games that I actually do understand. Let's see if we have questions. Nope, not at the moment. So here's an example of like you can actually make real-time strategy game maps, but you really got to make sure that you know what the real fitness functions are. So we were talking about PCG as basically generating content on its own, but we also have humans. And we cannot replace all aspects of the designer or even the human game developer yet. Of course, I'm looking forward to the future where we replace both the game designer and the player, and then computers can design games that computers play, and you know we don't have to deal with it. But we're not there yet, and some people don't want to be replaced. So let's look at how can algorithms and humans collaborate. So we have a human designer, we have a computation designer. If we let both of them take initiatives, and we have this sliding scale of initiative, so that we can even have a human as a primary, as someone who drives the design, and the computer as a slave or an assistant to help out with the design. We could also have a computer creating content and having the human as a guide or as a sort of someone who gives feedback on the content that the computer creates. That's usually called interactive evolution, but we'll talk more about the computer-aided design things of what side of things here. So there's a couple of examples of this from the recent academic literature. There's Gillian Smith's Tanagra, Antonis Liapis' Sentient Sketchbook, and Mohammed Shakar's Ropossum, where I've been involved in the two latter of these in some sort of supervisory function. Tanagra is a tool for generating platform game levels for something like Sonic the Hedgehog or similar games. There's a paper about that in Transactions, Computation, Intelligence, and AI in Games. It divides up the level in different beats, and then you can edit the beats, and you can decide on different things to keep, parts of the level to keep fixed, while it regenerates other levels and always assures a playable level. It's based on constraint solving, which is quite different from evolutionary computation, but can do some of the same things. And it's an interesting project I'd urge you to read more about. I'm not going to show you the video about this. We probably don't have time. Let's look at Sentient Sketchbook, which is a tool for generating map sketches for a large variety of games. We started focusing on real-time strategy games, but you could use it for a lot of different types of games. We used evolutionary computation in different versions here, and something called novelty search, which is similar to evolutionary computation. You have multiple solutions evolved, and they're shown in real time, and you have fitness based on area influence, exploration, and balance, so it basically evaluates the maps from different points of views. Let's have a look at how this, let me see here, there we go. So we start with the user selecting among a set of map sizes and starts creating a map. So we start with drawing bases. It's the white things here. And then you can put out resources. It's the blue things. These are sketches. They don't look like this is impassable regions like walls. They don't look like anything like maps yet, but they can be specialized to look like maps. We have different views here, the nav mesh, the resource safety. Okay, there are no safe resources, so maybe we should add some. Okay, the green line here shows that it's a safe resource. Are we in the safe areas? Well, these are the safe areas around the bases. They cannot be claimed by anyone else. We have unused space, so not so much of it, and you can segment the level automatically. At the same time as you're playing, you get this, on the left, you get these suggestions that are generated in real time as you generate your level. So basically, the user just selected one of the suggestions, and the set of suggestions are updated based on what is suggested. So every time you change something, it gives you new suggestions for how this map would look like if it was a bit more balanced or more fair or more sort of different from existing maps you've done. And then you can go on, of course, go on editing. So here's an example rendering into an actual strategy game, or perhaps like some other kind of game or a dungeon. We have a way of exporting this into StarCraft as well, and we've been working on ways of exporting from the same sketch into things such as platformers or FPS levels and so on. Yes, actually we can export to FPS levels in some format already, because structurally they're very similar, and you can easily translate from one to the other, at least the main features. So this is one example of how you can collaborate with your procedural content generation algorithms. I'm gonna check the question box. Nope, no new questions. So, Ropossum, or we can pronounce it Ropossum, is an assistive editing tool for a physics-based puzzle game called Cut the Rope. It uses grammatical genetic programming, which is a form of evolutionary computation, to create new puzzles, and it has a playability module that tests tests how puzzles can be solved using constraint research. And you can use design as input in complete or partial designs. We have a paper from last year about that. Yes, this is an example of Procedural, very popular mobile game. You are pushing around this little candy, and in the end you feed it to the green frog-like thing called onion. This is always makes me hungry to see. It comes with a good set of levels, but we decided that we wanted to try to find out how you could help players create playable, interesting levels automatically, so that you just have to have a vision of how you want it to look, and then the software performs all the sort of playability testing and so on. So here's an example. First, you can automatically generate level samples. So here's like sample levels. You press a button and you automatically generate playable levels using this grammatical or genetic programming. They look pretty weird because they're it's just they look pretty random. So as a human, you might want to design your own things. You can add ropes. You can add these bumpers, which the candy will bounce on. An air cushion, which will blow the candy away. Bubbles, which makes the candy float away. Turn things around. Add a rocket. Then you check for playability, and it's pretty interesting. So then it gives you. Let me actually post this. So you press the playability check, and it does a complete research to figure out if there is a way to activate different components so that the level can be solved. If it finds a way, it says that, yep, the level is playable, and then it shows you how to play the level. So if you pay attention up here, you will be able to find, you will be able to see a list of actions that you need to take in order to finish the level, as it automatically plays it. Rope cut, blower press, bubble pinch, rocket press. And now you won the level. So it tells you how to actually solve the level, and you can view the tree of all possible actions and how you could get to which ones end in dubs and which would actually solve the levels. Then you can keep some of your design. So you constrain it to keep some of your design and generate new levels that respect your what you kept. So now we're going to mark these things as fixed and generate new levels. Here's a new level, and that can be solved in a pretty simple way. That wasn't very fun, but it kept important parts of your previous design. I think we can generate yet another new one. Interesting. So we basically bounce the candy into the rocket, which falls down into Omlum. So it's a pretty complete package for helping you with all the sort of mechanical aspects of and all the sort of logical aspects of the level design, allowing you to basically do all the creative free drawing on your own. You can also do that on your own if you want to, but or the algorithm can also do that, but it allows you to do it. So oh, okay, I get a question here. No, still about sound. So I hope most of you can hear me anyway. So we talked about creating various types of content for the game, and now we will talk about, if we go one step further, can we create the whole game? You know, we don't have content. I mean, we don't have a game we're creating content for. We want to create a whole game. So here's an example. It's not from my own work. It's Cameron Brown, an Australian researcher who worked in the IT industry while also making board games for a long time. He was like a board game hobby designer. He wrote several books about board games. And then he decided to start a computer science PhD in his spare time, working on the weekends on automatic board game generation. Some people have a lot of energy. He decided by starting with constructing a language that can describe games, and a game engine that can play any game described in that language, and then use evolution to design games. He has a very simple description language, but it's very cleverly thought out for this particular genre of games. We're talking about things such as checkers, Go, Othello, Reversi, Connect 4, things like this. So simple games where you can put pieces of different colors, and then you might be able to move them, and it's all based on various connection properties, whether you win or not. Hex is also one of those games. So in his language, he has things called Ludi, the fundamental units of independently transferable game information. You can think of it as a game meme. So for example, that you have square tiling in a board, or that the size of the board is 3 by 3. Here's Tic-Tac-Toe. Tic-Tac-Toe, as you know, 3 in a row, is not the most impressive game ever. It's a very simple game. In fact, you're supposed to learn, you're supposed to solve it, but it's by the time you're 5 or something. But the interesting thing is that this is the full description of the game. It says there are 2 players, white and black. It has a square tiling iron neighbor's board, size 3 by 3, and you end for all players. You can win if you have 3 in a row, and that's a full description. So you can take this small program snippet, feed it into the Ludi game engine, and you get the complete game which you can play. You can also change things. If you add another 3, suddenly you get a 3-dimensional 3 in a row, which is marginally more interesting than 2-dimensional 3 in a row. Here's an overview of the system. He starts with a big population of games at the big oval at the top here. He encoded something like 50 existing board games in here. And then in each generation, he selects parents, crosses them over, mutates them, and checks the rules. Are the rules well formed? For example, there is a way to start the game, there is a way to win the game, there's a way to lose the game, there are always moves you can take, etc. Then you continue, otherwise you throw it in the bin. And you start over, and they select new parents. So if the game is well formed, you baptize it. He had a name generator as well, using sort of Tolkien style names, or generating Tolkien style names. He checks, is it too slow? If it is, he throws it in the bin. Otherwise, he chooses a policy to play it. So he evolved an evaluation function, or he learned, an evaluation function for a min-max tree search that could play it as well as possible. Is it drawish? So basically, most of the time, no one ever wins. Well, then throw it away. Otherwise, check, is it inbred? Is it too similar to other games? Throw it away. No, otherwise, you give it a fitness using a very complicated evaluation function here based on letting a number of people play existing games and rank them, and then you throw it back into evaluation, or in population. So this continued. He let this go. I think the full experiment took weeks. And he came up with a number of interesting games, including Yavalath, which is a relatively simple game, which you win by having 4 in a row, but you lose by having 3 in a row, and it works on a hex board. This is the full description of it. The interesting things with this Yavalath game is that it was deemed so novel and so good, so we could actually put it in a box and sell it in game stores and actually make money out of it, which is pretty great, He managed to invent the first computer-generated commercially successful games. Then you might argue if you're a philosopher about the thing that he's taking the credit for it and not his algorithm, but I think it's cool. So, but that's board games. Let's go beyond the board games to other kinds of games. I'm just going to see if we have questions. No. So I did, at about the same time, I did an experiment in trying to generate simple Pac-Man-like games. We have this rule encoding, what happens when things collide, and we try to evolve games rules for games that would be as learnable as possible. What's this idea that a good game is a game which is not playable by random. If you just do random actions, you're not able to play it. You're not going to win it. But if you try to learn it, you will eventually get good at it. So a good game is learnable. There's a lot of psychological literature and also game design literature, like, for example, Ralph Costa's work that really supports this viewpoint. And I was personally quite inspired by Dwarf Fortress work. Unfortunately, this particular experiment was a bit limited in its both the computational power we had and the and rule representation, so we didn't actually come up with any interesting games. But I still think the basic idea is sound, so we continued working on this. And now we have something we call the video game description language. It's a description language that's developed in order to be able to represent most games from the Atari 2600 era and many from the Commodore 64 era. So we wanted to be able to represent any, basically a very large space of these games, simple arcade games, in a simple language. It assumes two-dimensional movements and graphical logic, which means that things move around on a flat screen and things happen, like things die or teleport or whatever. You get score or lose score when things collide on the screen. It's supposed to be compact, humor readable, and we have game engines in Java and Python for this. In fact, we also have a competition about writing AI for games in this. It's called the General Video Game Playing Competition. Here is a game. It's a complete game. You might not see it immediately, and you might not understand what happens here. But this is the game Balderdash, the classic 80s game, huge hit on the Commodore 64. There's like for every new video game generation, there seems to be a new version of Balderdash released. There's one for the 3DS now recently. It has the language has these different parts. A sprite set decides what there is in the world. Level mapping that decides how to map from level description to the game ontology. Interaction set, which is sort of the core of the rules, what happens when things interact with each other, and how you can win or lose the game. And here is what it looks like, Balderdash, in our representation. The little guy in the middle of the screen is the player, and there are different monsters. There are boulders which can fall down, and diamonds which you need to collect. And then at the bottom, close to the left end of the screen, there's a door which you can only exit after you collected at least 10 diamonds. So it's a pretty sort of, it's not the best version of Balderdash, but it's a pretty faithful clone of it. It's interesting is that we have it in this generic language, which can also represent the mechanics of a whole bunch of other games, including classics such as Lunar Lander, Frogger, some parts of the Zelda mechanics, Missile Command, and yeah, we have like 20 classic arcade games represented in this way. Here's a random player playing Balderdash. He's not playing very well. Running around, getting himself killed. Right. Here's a Monte Carlo tree search controller, which is a pretty recent statistical tree search algorithm playing the same game. As you can see, he is not playing optimally, but he's playing relatively well. For some reason, there's a visualization artifact where some of the enemies appear to be inside walls, and boulders appear to be jumping. Boulders are not really jumping. Disregard that. It's the visualization. But the player is doing okay. He's running around, looks to be a bit lost. His search depth is not really great enough, but he's pretty good at getting all his diamonds and actually winning the game in the end. Yep, there we go. So here we have an example. We have these representational games, and we can automatically play them, which means we can automatically evaluate them. So I have this vision that we're moving towards a space where we are coming up with general game playing algorithms that can play games in general, and then we automatically, through evolution, generate complete games, and we also generate levels, and we need to generate games in order to generate levels. We need to have good game players in order to test the games we're generating. We also need to have good levels in order to be able to play the games, and good players in order to test the levels we're generating, etc., etc. It all really fits into each other in various ways. And I think that's something that many of us in the university world will try to push towards, this sort of circle of general game playing, general game generation, and general level generation. It's probably not something that will be directly useful for the industry in the short term. In the long term, it really might be. But as I hope I have been able to show you, there's a lot of other, there's a lot of other sort of more direct approaches, like these sort of assisted design tools, which where these algorithms can be useful for commercial game production. Could we generate any type of games? It will be hard to try to generate even line. It's a bit complicated, you know. First we need an algorithm that plays it and then generates it. But I think that if we're into generating games, we should focus on simple short games, or like short game atoms, where the sort of the basic gameplay, the basic unit of gameplay is relatively short. One player, maybe two players, one player with just 1.5 is one player with NPCs. Yeah, it's easy, they're learnable, easy to acquire heuristics, clear outcomes, ending conditions, not too high branching factors, you can play it with an AI, and preferably deterministic games. So, and that is essentially what this video game description language is aimed at. So it's sort of a vehicle for creating complete games of the type that I think we could actually generate, which I consider is one of the most interesting challenges that we have in PCG research currently. And of course, this is not the end of the game design. I mean, our AI is nowhere near good enough to generate complete games yet. We are good enough to generate simple levels for Super Mario Bros. Or for like Civilization or something like this. But there would always be need for human supervision and human sort of vision, supervision, right? Especially humans that have supervision. Well, I'll stop now. Anyway, but it is, this kind of work is really moving towards, like all kind of technology, and especially all kind of AI, eliminating all the sort of repetitive and low-skill design tasks and try to sort of automate them. When you look at how game production really looks like currently, we have so many people involved in making a game, hundreds of people, and many of them do QA or like, you know, repetitive parts of generating the game world, and we're trying to sort of, you know, get rid of all that in order to both be able to make better games, in order to make, and also in order to make it affordable to develop affordable to develop games without having hundreds of employees for doing all kinds of parts of the game. Right, it is the end of this talk though, and I will stay online. I see I overstayed my welcome. Well, no, I overstayed the hour, and most of you are still listening to me. I will stay online for a few minutes to answer questions, depending if any questions show up in the question box. So please write some. And in the meantime, there's more about me on my webpage. There's more about PCG on the PCGbook.com, and more about general video game playing and the video game description language on gvgai.net. So let's see if I actually have any questions. Okay, how would you, and Rob Stamper asks, how would you approach using algorithms to generate certain sections of game path that would need to be seen together with fixed assets, which could themselves be generated by a separate set of algorithms? How would you approach bridging the two seamlessly? That's a lot. That's a big question. So yeah, so there's there are a couple of approaches to actually sort of bridging different procedural content generation solutions. There is something you can check that I'll just type into the box here. Sketch your world. Oops. Did this disappear now? Show answered questions. It's one way of combining lots of different algorithms with human authoring. But I'm not really sure what you mean with fixed assets. One way of using the fixed assets is to actually include them as the basic building blocks of your whatever you're evolving. If you use search-based PCG and involve sort of fixed assets that are put out in different ways. And if you have a particular path you need to follow, you can use that as, you can have the constraints in your evaluation function that everything gets fitness 0 if you don't, if it doesn't include that particular path. I'm not actually sure I get all of your answer or all of your questions, so if you could specify it a little bit more, I could answer it in more detail. I also have a question from Nishan Sud about the master's degree at ITU Copenhagen. It's better if you actually mail me about that, and I can answer you in person about that. And you find my mail address on my webpage. Do we have any more questions? So I'm not sure I'm able to answer the question about like fixed assets. I think you should have fixed assets as part of representation, and the path you should be able to, and the path you need to have in there as a constraint in the algorithm. But apart from that, that's I think that's it for the questions, and I think that's it for me. So I hope you enjoyed this, and thanks a lot for watching, thanks a lot for listening, and yeah, have a nice evening.